Good day everyone. Our topic for today is all about graphs, a system of linear equation in two variables. System of linear equations. Graphing a system of two linear equations and two unknowns gives one of three possible situations. Case 1. Lines intersecting in a single point. The ordered pair that represents this point is the unique solution for the system. So as you can see in our figure, there are intersecting lines, one solution. So the point here is a point represent the solution of the system. Case number 2, lines that are distinct parallel lines are therefore don't intersect at all because the lines have no common points. This means that the system has no solution. So this one is our parallel lines. Therefore, no solution for this. It's very obvious because these two lines doesn't have the same points. And case 3, two lines are the same line. The lines have an infinite number of points in common, so the system will be an infinite number of the solution. So we have two lines that are in the same line. These are the infinite number they have the infinite number of solutions. So graphs and conclusion. If the two graphs are intersecting lines, these are independent, consistent, and has one solution. If the two graphs are parallel lines, then they are independent, inconsistent, and no solution. If the two two graphs or two graphs coincident lines, then they are dependent at the same time consistent and infinite solution. So this will be our summary for the discussions about the three cases that I mentioned a while ago. So using the x-intercept and y-intercept, let's try these two equations. So for these two equations, we have x plus y equals 4 and 2x minus y equals 2 as our equation 1 and equation 2. So step 1, find the x-intercept and y-intercept of the two equations. X-intercept is the point where the graph of the line intersect the x-axis. So let's suppose that if we will find the x-intercept, let's suppose that y is equal to 0. If y is equal to 0, okay, then we will just substitute 0 to y, so we have x plus 0 equals 4. And obviously, we will cancel this, so we have x equal to 4. Okay, that will be for the x-intercept. For the y-intercept, is the point where the graph of the line intersects the y-axis. So let's suppose that x is equal to 0 using equation 1. And if it is 0, that will become 4. So we have 0 and 4 as our y-intercept. Same with this. So we have 0 for the y, and this will become 2x equals 2, and 2 divided 2 is equal to 1. That's correct. If x is equal to 0, then negative y equals 2 becomes y equals negative 2. That's correct also. Then we will plot all these four using the graphing or the Cartesian coordinate system. So graph each equation using the x-intercept and the y-intercept using the same rectangular coordinate system. So we have this equation a while ago that we had computed, right? So we have 4 and 0 for this 4, 0. So the point will be on the x-axis. Y, y-intercept, so therefore the point is on the y-axis. For the x-intercept, x is 1. And for the y-intercept, the point is on the y-axis, but it is negative, so it is downward. Okay, so we will get the graph for this. So this is the graph of this equation. Okay, and for this we will 0 and 4, so we will put a line. So this will be the graph of this equation, or simply this line is equal to x plus y equals 4, and this line is equal to 2x minus y equals 2. So that's how we graphed a particular equations. Okay, given the two equations. Okay, you just get the y-x-intercept and the y-intercepts of the given equations. If depending how many equations there are. If there are five, just get the y and the x-intercept, and then just follow the same procedure that we've done. The step one and the step two. So that's all about graphs, a system of linear equations into variables. Thank you very much for listening.